Hi, so what we're going to do today in this video is differentiate the function tan squared. So d by dx of tan squared of x. So that's what we're going to do today. And again, similarly to my previous videos when we differentiated sine squared and cos squared, we're going to need the chain rule. And we're also going to need to remember a result from, again, one of my previous videos, that when you differentiate tan of x, you get sec squared, so the reciprocal of the cos function squared. So that result is going to help us out with this. Sorry, my alarm's going off. So yeah, we're going to do this derivative then. So again, just to emphasize, we're differentiating the tan function all squared. So yeah, this is obviously going to be the chain rule. So what we want to do is differentiate the inside of this squared function first. So we're going to differentiate with respect to the variable x, the tan of x, and then we're going to multiply that by the derivative of the squared function with respect to the function within that squared function, to the tan of x. So differentiate tan squared with respect to tan. And so if we do all of this then, what we're going to get, so the first part is the derivative of tan, so we know that's going to be sec squared, and the derivative of the squared function, so we know that when you do the derivative of x squared, that's just 2x, so this is just going to be 2 tan of x. Okay, so perfect. So now we can just write the final answer out. So d by dx tan squared is going to be 2 and then sec squared x times by tan x. Okay, great. Yep, so that's the derivative of tan squared. I guess we could rewrite this in a different way using a trig identity. So we know that 1 plus tan squared from trig identities is identical to sec squared of x. So I guess we could rewrite this just in terms of tans. So this is going to be 2 times 1 plus tan squared of x times by tan of x. And so this will be 2 tan, and then plus 2 tan cubed x. Okay, perfect. Yeah, so that's another way that you can rewrite this this result. And so if we want to generalize this, so similarly to what we did when we differentiated the sine squared and the cos squared functions, if we want to generalize the power to a general real value of n, so let's say we want to differentiate tan of x all to the power of n. So again, a very similar procedure. Let n be a real number. So yeah, so what we're going to do is differentiate the tan of x within the power of n function. That gets us a sec squared of x. Multiply that by the power of n function, the derivative of the power of n function. So that's going to be n times by tan to the power of n minus 1 of x. And so simplifying this result, we get n times sec squared of x times by tan n to the minus 1 of x. And again, we can rewrite this in a different equivalent format. So n times 1 plus tan squared of x times by tan n to the minus 1 of x. And so we get n times by tan to the n minus 1, and then plus n times tan n to the plus 1 of x. And these two results down there are exactly the same, and that would be the answer for this derivative.